about this number. When I match it up to my place value chart, I can see that the last decimal place ends at the thousands. So I would say this number as 375 thousandths. Be careful that you are not calling this number 375 thousandths because that's not how we say it. And only belongs where the decimal point is. So we would say this number as 375 thousandths. So if you wrote this out as a fraction, you should have gotten 375 over 1,000. 375 over 1,000. Now, I absolutely know that this is not in the most simple form. So I'm going to go ahead and set this up into my fraction ladder. So I'm going to put 375, and I'm also going to put 1,000. And I'm going to put my bracket around it. And I want to see how many times I can find a number that will divide into both of these. So let's just start with, what if we start with something simple? What if we start with something simple like 5? Because we know that 5 will go into both of these. And maybe my brain is just not thinking today and I need to start simple. So I need to think, how many times will 5 go into each of these? Well, it might be helpful for you to divide this out. So if I had to figure out how many times 5 goes into 375, I can write it out like a simple division problem and I can work it. Don't be afraid of doing these steps. Don't give up too early. How many times can 5 go into 3? We know it cannot, but 5 can go into 37, and it can go in 7 times because 5 times 7 is 35. When I do that, I'm going to get 2 left over for my difference. And then I can figure out, I can bring this 5 down because I know 5 can't go into 2. How many times can 5 go into 25? It evenly goes in 5 times, and that gives me a remainder of 0. So I know that 5 can go into 375 75 times. And then I want to figure out how many times can 5 go into 1,000. And so I want to show you this way, but I also want to talk to you about a trick you may already know. 5 cannot go into 1, but it can go into 10 2 times. And that gives me 10, which is 0. And I got to still bring these zeros down. And when it will not go in, I will just add my zeros here and I get 200. But another way I can think of this, I can isolate these zeros here and I can ask myself how many times will 5 go into 10? 2 times, and there are 2 zeros left over, so I can just add those 2 zeros to the end. So now I'm looking at 75 and 200. So let's add another step on our fraction ladder. And for my next step, I know that there's something that can go into these again. I could do 5 again if I'd like to do 5 again. Let's do 5. Let's just do 5 for the fun of it and see how far we can take this out. Some of you may have already noticed that 25 could also go into both of these numbers, and that would get us there much quicker. But some of us struggle to know that 25 can go into these larger numbers. I mean, it's more difficult working with the larger numbers. So I want it to be as simple as possible. So I'm going to think about how many times will 5 go into 75? Well, I know that 5 will go into 50 10 times. And I know that it will go into the remaining 25 5 more times. So I know that 5 will go into 75 15 times. And I know that 5 will go into 100 20 times. So it will go into 200 40 times. All right, let's look at these numbers. Now I'm sitting with 15 and 40. Can I go any lower? 2 cannot divide into this, but I already know that both of these numbers are divisible by 5 once again. So I'm going with 5 again. 5 will go into 15 3 times, and 5 will go into 40 8 times. So now I have the simplest form I can get because the only thing left is 1, and I know when I'm at 1, I'm done. So now I have 3 eighths, and I have simplified the fraction 375 thousandths as 3 eighths. And so I have taken 375 thousandths and I have generated an equivalent fraction for that. All right, let's try something a little bit different. Let's try taking a decimal that may have a whole number in the front, and let's try changing it into a mixed number type fraction and then seeing if we can convert that into a decimal. So what if I have a number like 9.25? 9.25. Now I'm saying, I'm sorry, let me change that to 9.85. I'm saying point, and I absolutely know that's not the way to say this number, but I'm trying not to give that away for you. So I see 9, a decimal point, and 85. So I want you to take just a minute and think about how would you say this number as a decimal. Go ahead and do that. Okay, so you should have said 9 and 85 hundredths because the last decimal place ends at the hundredths place. And we say 9 is a regular whole number and represents the decimal. So 9 and 85 hundredths. So if I were going to write this out as a fraction, I would write it as a larger 9. It's going to be a mixed number. And 85 over 100. If I say this fraction the same, it's true that I'm also going to say 9 and 85 hundredths, just like I would say the decimal 9 and 85 hundredths. So they are the same number. They are equivalent. One is just a fraction, one is a decimal. And so now I need to simplify this. My 9 is going to stay just the way it is. It's going to stay the same. But I need to simplify the 85 100ths. And so in order to do that, I know 5 can go into each of these. So I'll just try it with 5. And let me see how many times I can get 5 into each one of these numbers. And I know that 9 or 5 will go into 85 17 times, and 5 will go into 120 times. That's been a popular number today. And I just continue with my 9. So I add it there at the front, and I'm left with 9 and 17 twentieths. 17 twentieths. So 9 and 85 100ths is equivalent to 9 and 17 twentieths. And it's very simple and basic the way that we work that out. All right, I'm going to give you one, and I want you to practice it on your board. Let's do the fraction. You know what? Before we do that, let's review just a little bit how we went from fractions to decimals. I want you to remember, if I give you the fraction 3/5, I want you to take this fraction. I want you to put the denominator at the door, that down in the dirt denominator, put it at the door, put a 3 in the house. I want you to solve this and get a decimal. And then I want you to write your decimal as a fraction. And then I want you, when you get your decimal, I want you to write it as a fraction. Then I want you to simplify the fraction. So I'm going to have the video pause, and I'm going to let you go through this. And when the majority of you are done, then you guys can come back and you can watch us do this together. Okay, so let's talk about how you did this. You should have put your down in the dirt denominator at the door, and your 3 should have gone into the house. Now, 5 cannot go into 3, so I hope that you added your decimal point in your 0. Remember that some people like to put in this space saver here, this 0. And now we can divide 5 into 30. And 5 will go into 30 6 times, and it is an even 30. So I'm going to be left with 0 as my difference. And I can stop there. I've got 0.6. And now you should have taken this number and thought about how I would say it as a fraction or as in my place value. And we would say it as 6/10. So if you said this number as 6/10, then you have created a fraction that is equivalent to 3/5. So 3/5 is the same as 6/10. Now, if you have already caught on to this part, you know that 6/10, if I simplified it, I'm going to get 3/5. And the way I would do that is I could divide each one of these by 2 because it's the number that comes to my head first. And I'm going to get 3/5, which is the simplest form. It is the same as the fraction that we started with. We just found a fraction that has an equivalent decimal that also has another more simplified, a greater fraction. And when we simplified it more, we come back to our 3/5. So you can see how they're all equal. Let's practice with another one. Let's do 14 over 25. Now, this one's going to take you a few more minutes, a little extra time. I want you to put 25 at the door, 14 in the house, and I want you to solve this. Come back to the video when you're ready. Okay, so you should have put 25 at the door and 14 in the house. And I know that 25 cannot divide into 14, so I need to add my decimal and my 0. And now I know that 25 can go into 140. I'm thinking in terms of quarters here. It can go into 100 4 times. It can go into 125 5 times, but I can't add one more because I would be at 150. So 5 times would give me 125. And when I subtract, I have to go next door, I have to borrow. I'm going to get 15 as my difference. 25 cannot go into 15, and we don't deal with remainders anymore. We add and annex a 0, and now I'm left with a great number of 150 because I know 25 can go into 150 equally. And we said just a minute ago that it would be 6. So 150, and I have 0 as my difference. I can stop there. Now I'm left with 56 100ths. And I'm sure you discovered if I simplified that, I would be right back to 14/25. All right. Let's see what we can do, and let's see how you guys are looking time-wise. And if we have a little bit of time, you guys can go on. If not, we'll go ahead and stop you can go ahead and stop the video now. But here's what I want to do. I want to give you a mixed number like 1 and 3/8. So let's take 1 and 3/8. And I want to talk about how we can split this up and we can simplify it a little bit. What if I wanted to say that I need to represent this as a decimal? I want to represent this as a decimal. So here's what I would need to do. I'm going backwards now. I'm going from a fraction to a decimal, but I'm doing it with this 1 here. And so the way I would do that is I would isolate this 1. It's over here now and it's by itself, and we're just going to let it sit there for a few minutes. I can just work with this 3/8. And so I would put my 8 at the door and my 3 in the house. I know it can't divide, but my 8 can go into 30. And 8 can go into 30 3 times. And it's going to leave me with 24. And so when I subtract to get my difference, I have 60. Now I can keep annexing zeros as long as I need to. You need to start thinking about how many times could 8 go into 60. Now, some of us, we're really getting tricked up on our 8s still. You know your 9s now. If I were to try 8 times 9, 8 times 9, I'm going to get 81. And I know that's too many. So let's take it back a few steps. You know that 8 times 4 is going to, 8 times 5 is going to give you 45. And that's not quite enough. So somewhere in the middle there is what we're shooting for. So if we did 8 times 7, that would give us 56. And I'm left with 4. Now I can annex another 0. 8 can go into 40 and equal a number of times. And it's 5. So that gives me 40. And I'm left with 0. So I can stop there. Now, don't forget about this 1. It's still sitting over here. I just moved it on by itself. But I have taken 3/8 and I've converted it into a decimal. And I got 0.375. And so 0.375 can be said as 375 thousandths. So if I were to write that out, 375 thousandths. Now I have this big fraction, right? I have this big fraction that I could convert out if I wanted to. I know that it would get me right back to, I could simplify out and get me right back to 3/8. But what I want you to see is this 0.375. And so 0.375 is what I got when I took my fraction and converted it to a decimal. Now, I'm not forgetting my 1 over here. It's time for me to bring it back. And if I put this 1 here, it's my whole number, 1. I can add my decimal to the end, 0.375. Now, I can see that 1 and 3/8 is the same thing as 1.375 or 1 and 375 thousandths. There's the 375 thousandths. It is equal to 3/8. So essentially all I did was took 3/8 and I multiplied it out, and I got a great big number until I got 1,000 on the bottom. So it was easy to say. And that was one way that we just went around it. We used the method that we know. We took our denominator, put it at the door, we divided it out, and we were able to see that we got 375 thousandths. And when we put that with the one, the whole number one that we had sitting over here on reserve, you can't forget about that, because we can't end with just 375 thousandths. We have to add that one back in there. All right. At this point, if you are almost out of time, you can go ahead and end the video now. Thank you guys for paying attention. If not, I'm going to go ahead. I'm going to leave several problems here on the board for you guys to work out. Try your best. Do some practicing. You may either work them out on paper or on your dry erase board, but I do ask that you return your dry erase markers with the lids on back to the drawer, and that you return your dry erase boards back to the shelf when you're finished. So let's get started with a couple that you can try to solve on your own. Go ahead and try 0.4. Convert this into a fraction and then simplify it if it can get any simpler. Once you've completed that one, I want you to try 0.64. Think about how you would say that. And next, I want you to try a mixed number. I want you to try 2.75. Put that 2 to the side, reserve it. I want you to take the 75 hundredths and I want you to convert that into a fraction and see if you can solve that. And then let's do a fraction. Let's do an improper fraction. Let's do 7 halves. 7 halves. And I want you to work this out the exact same way that you know how. When you get your decimal, it's going to have a whole number in the front. So I want you to take that whole number. I want you to use it at the front of your decimal. And then you can even change this back into a mixed number if you can figure that out. So let's go ahead and try these out. If you get them and you're feeling really good about that, I want you to think about how you would rate yourself. Are you a 1? You're really stuck. Are you 2? You're kind of getting it, but you're going to need some more time with me tomorrow. Are you a 3? You have got this and you feel really good about it. Or are you a 4? You feel like you are a master at this skill and you feel like you could help me tomorrow when I reteach this. So I want you to be thinking about, where do you fall here? If you have more time, I'll write out a few more math problems and I'll leave them with your teachers so that you can solve them. I'll see you guys tomorrow.